Okay guys, so today we really need to review the law of sines. So we have that quiz tomorrow, remember? So I think we should first talk about what it is and then how and when to use it.
Yeah, good idea. I always get confused when I should use the law of sine and when I should use the law of cosine. So let's clear that up too.
Alright, so the law of sines is used when we have either an ASA or angle side angle or AES angle side triangle. Also, when it is an SSA side side angle case, but that can be tricky sometimes.
Exactly. Basically, when we know enough angle and side in a triangle but not all three sides or all three angles yet. Yet the law of sine relates the side under opposite angle. It says A over sine A is equal to B over sine B. It is C over sine C. Where AB and C are the side lengths and AB and C are the opposite lengths.
Yes. And the important thing is the ratio. Side over sine of the opposite angle, it's consistent across the whole triangle.
Hold on, let's be very basic first. So why do we even need the law of sines?
Good question. We need it because sometimes when solving triangle, you don't have the right angle. So you can just use basic SOHCAHTOA or Pythagoras. The law of sine helps us when the triangle is oblique, meaning not right triangle.
Exactly, and it lets find unknown sides of unknown angles easily using what we already know.
Let's try a small example so it sticks. Suppose we have a triangle with A is equal to 40 degrees and B is equal to 60 degrees and side A is equal to 6 centimeters. Find the side B.
Alright. First, according to the law of sines, A over sine A equals B over sine B. Substituting the values 8 over sine 40 degrees equals B over sine 60 degrees. Now cross multiplying B equals 8 times sine 60 degrees over sine 40 degrees. And we just use the calculator.
Let's compute that. So sine 60 degree is about 0.8660 and sine 40 degree is about 0.6428. Multiplying 8 times 0.8660 equals to 6.928. Then dividing 6.928 divide 0.6428 approximate 10.78. So B approximate 10.78 cm.
Nice! See, it wasn't too bad. So the steps are step 1. Set up the proportion using side and opposite angles. Step 2. Substitute the known values. And step 3. Cross multiply to solve for the unknown. And step 4. Use the calculator carefully for sign and division.
Yeah, but what about solving for angles? Like if we know two sides and one angle?
So that's where we use the inverse sine function. Suppose the side alpha is equals to 7 and the side beta is equal to 10 and the side angle gamma is 30 degrees. We want to find the angle B. First again, A over sine A is equals to B over sine B. So we have to substitute 7 over sine 30 degrees equals to 10 over sine B. Since sine 30 degrees is 0.5, 7 over 0.5 equals 10 over sine b. So 7 over 0.5 is 14. So 14 equals 10 over sine b. So we have to cross multiply. So it will be 14 times sine b equals 10. So let's divide the both side by 14. So it will be sine b equals 10 divided by 14 sine b is equals to 0.7143. Then finally, the angle B is the inverse sine of it is 0.7143. So if we use the calculator, the angle of B is 45.57 degrees.
Great! But don't forget, always check if your calculator is in degree mode. Otherwise, your answer will be wrong.
Definitely. One time mine was in radians and I couldn't figure out why my answer is so weird.
Same. So okay, when we solve for angle, after getting the sine B value, we press shift or second then sine button to use the inverse sine function.
Exactly. Also, let's not forget something important. In SSA cases, sometimes there could be two triangles possible. One triangle or even no triangle. It's called the ambiguous case.
Yeah, that's one tricky part of the law of sine.
So, quick review. If A is less than B and A is less than B times sine A, no triangle. If A equals B times sine A, one right triangle. If A is greater than B, one triangle. If B times sine A is less than B, there are two triangles.
Maybe we should do a sample of the ambiguous case to see it.
Sure. Suppose A is equals to 7 and B equals to 10 and A is 30 degrees. First, compute the B times sine A. So it will be 10 times sine 30 is equals 10 times 0.5 or 5. Now, compare to B times sine A, 7 is less than 5. So a triangle exists. Also, since A is greater than B and A is less than B times sine A, two triangles are possible.
Which means two different possible angles for B.
Right. After finding one value for B, the other possibility of 180 degrees is negative B.
And both can give valid triangles, provided the sum of angles is less than 180 degrees.
Well, so it's a bit complicated when it's SSA but otherwise law of sines is friendly.
True. So to summarize everything, use law sign when you have a ASA or AAS or SSA triangle. Set up the proportion side over sine of its opposite angle. Solving for missing side or missing angle, use inverse sine or sine to the power of -1 to find the angles. Watch out for the ambiguous case in SSA.
And double check that your calculator is degree mode always.
Let's also list common mistakes students make so we can avoid them. Forgetting which side matches which angle, not cross-multiplying properly, forgetting to press inverse sine for finding angles. Calculator is set in radians by mistake, not checking for the possibility of two triangle and SSA.
Nice list, and don't rush. Take time setting up proportions correctly. If the proportion set up is wrong, the whole answer is wrong.
Agreed. Before we end, let's do a final fast question. In a triangle, A equals 50 degrees. A equals 9 cm, B equals 12 cm. So, let's find angle B.
Alright, using A over sine A equals B over sine B, 9 over sine of 50 degrees is equals to 12 over sine B. So sine 50 is equals to 0.7660, so 9 over 0.7660 equals 11.75. So 11.75 equals 12 over sine B. So let's cross multiply 11.75 times sine B equals 12, then divide sine B equals 12 over 11.75 equals 1.0213.
Wait, that's more than 1. That means no triangle is possible with those given measures.
Exactly. A sine value can't be greater than 1, therefore no triangle can be formed.
Good catch. See, understanding the law of sines help us notice impossible cases too.
Awesome discussion, team. I feel so much better about tomorrow's quiz.
Same. Let's ace it.